Let's start with this new topic, buckling of columns. And it's also called as elastic stability of columns. I just kept a sticky here. Okay. Guys, now, suppose if I want to actually apply force and break the stick, applying some force here, and I'm applying too much of force, I can't break it. Even if I try to do this, it is actually, it hurts me, and I'm not able to break it, this stick. But if I actually, the same stick, I'm trying to hold it like this, but I'm able to break it. Suppose if I apply more force, it breaks. Which means that if something is shorter, then it behaves very differently. If something is very long, then it actually the way it fails is completely different. There it was actually failing by what is called as crushing. Here it is failing by bending. So therefore the ability to take loads are very, very low. So I think people started to worry about this, and they wanted some equation which would give you what is the load that these members can take. Around 300 years back, one person named Euler, I think everybody know about Euler, no? I think some great people do a lot of things, and one of the things that Euler has done is this. Okay? And what he actually did was, he actually made an equation, and that equation was called as Euler equation. He gave P is the load, and CR stands for crippling. Crippling is same as buckling. So buckling means you showed, I think, any vertical, any long rods like this, any long elements like this, when applied with a load which is called as P, they actually start to bend like this and fail. At some point they fail due to this excessive bending. Okay? He could actually make this equation. And of course there is also derivation, there is also mathematics behind this, and that one of the derivation will be asked in the internals. And he actually gave a very common equation, so that is called as the Euler equation. So Euler equation is given by pi square EI, I minimum divided by LE square. This is called as the Euler's equation. I think here, you know what is pi, 3.14. What is E? Young's modulus of the material, like 200 GPa or something they give it. And I, you know. What is I? Moment of inertia. Moment of inertia, what type of column this is? It depends on the column here. Whether this column is actually a rectangular column, and whether this is rectangular column, or whether it is actually square, or whether it is a circular column. So you can use this. Suppose if it is a rectangular column, if it is a rectangular column, then you know that here this is B, this is D. Okay, this is B and this is D. And rectangular columns can have two I values. One is about this axis, where this is B and this is D. Otherwise, rectangular columns can have way like this, where this is B and this is D. Okay, which do you think will have low value of I? Now whether I is equal to, you have BD cubed by 12 like this, so B is actually breadth like this, BD cubed by 12. So you can call this as B. You can call this as B now. So in this case it is BB cubed by 12. So sorry, this is breadth. This is okay. Now whatever you want to call it as, you want to call this as depth like this. So which case will have larger value of I? The first one or the second one? The first one will have maximum. This will have a large value of I, and this will have a smaller value of I, because this value of B is smaller, D cube is smaller, so this will have which is a smaller value. So which means that you need to take out of this two, if it is actually a rectangular section applied with a load like this, it will try to bend in the direction of the least resistance. If you hold a scale in which you use to draw a line, no, or measure centimeters or mm, if you hold a scale and press it, which side the scale gets bent? The scale gets bent in the side which is actually thinner. So that is, the materials tries to buckle themselves in the least resistance direction and they fail. So therefore, this has to be substituted as I minimum, because I will where here, okay, for this rectangular section you can calculate I like this, keeping the breadth smaller and the depth larger. Otherwise you can keep this breadth larger and the depth smaller. So whichever is minimum, that value of I has to be substituted here. And then LE stands for effective length. Effective length actually depends on the end conditions, the effective length. So LE stands for LE, effective length. Effective length, and this effective length stands on, okay, depends on the way we hold this this two ends of the column. You can actually hold the two ends of the column in different ways. If you see here, I can actually hold it like this. I can actually hold it like this. I can actually hold it like this. I can hold it like this and apply a load like this. I can hold both sides like this. I can hold one side like this and one side like this. One side like this. Sorry, one side like this. So there are four ways. One is actually holding like this. Holding like this means it is almost like hinge. So that means I am applying a force. It is like a hinge. That means this end can rotate about itself. It is almost like hinge here. And other two is holding it tightly like this. Holding it tightly like this. And the other is, one way holding it like this, other is hinge like this. And one is holding it tightly like this, and other end is free to move in any direction. It bends like this. There are four ways. So for these four ways, the values of LE that you substitute are different. Okay. So for this, you should know these four values. So let me actually draw below these four different ways in which you can actually hold the column. Okay, let us see the first one here. Let us see the first one. So first one is holding the column like this. So that means holding the column like this. So here you are applying load here. This is the stick. This is the stick. You are applying load, and the stick starts to bend like this. It is like hinge only. It is like hinge. Holding like this and holding like this is different, no? So you are holding like this. It is bending like this. So it starts to bend like this. It starts to bend like this. Let me use other color. Okay, like this. I show you here like this. Okay. So here, this actually bends like this. So here, the whole column participates in bending. So therefore, this, in this case, we call this LE as the whole length of the column. And this is called as both ends hinged. This is called as both ends hinged. Okay. And here you will see that when you are applying load, you are actually restricting this movement going sidewards. You are applying this movement as if this end will not actually move sidewards. The end will not move sidewards. You will try to go like this only. You will try to hold the same line. Okay. For both ends hinged, you have to substitute LE as the actual length of the column. If the column is 100 mm, you have to substitute 100 mm here. Okay. Then the next case is one end fixed and other end hinged. So here fixed means like this. One end of the column is fixed means okay, I'm holding it like this. I'm holding it like this. Other end is hinged like this. You can see the difference, no? ಯಾವ ತರ ಆಗ್ತದೆ ಅಂತ ಹಿಂಗೆ ಹಿಡ್ಕೊಳ್ಳೋದಕ್ಕೂ ಹಿಂಗೆ ಹಿಡ್ಕೊಳ್ಳೋ ಡಿಫರೆನ್ಸ್ ಇದೆ ಅಲ್ವಾ? Okay, so it is like this. So can you see the shape? Can you see the shape here? So here also we have this load ಆಗ್ತಿದ್ರೆ ಅದರಲ್ಲಿ ಲೋಡ್ ಆಗ್ತಿದ್ರ ಒನ್ ಎಂಡ್ ಇಂಚ್ಡ್ ಯಾವ ಕಡೆ ಎಂಡ್ ಇಂಚ್ಡ್ ಇಲ್ಲಿ ಈ ಕಡೆ ಕೆಳಗಡೆ ಬಂದ್ಬಿಟ್ಟು ಇಟ್ಸ್ ಆಕ್ಚುಲಿ ಗೋಸ್ ಲೈಕ್ ದಿಸ್ ಇಟ್ ಆಕ್ಚುಲಿ ಗೋಸ್ ಲೈಕ್ ದಿಸ್ ಇಟ್ ಇಸ್ ಆಕ್ಚುಲಿ ಗೋಯಿಂಗ್ ಲೈಕ್ ದಿಸ್ ಇದು ಒಳಗಡೆ ಹೋಗಿದೆ ಈ ತರ ಇಟ್ ಇಸ್ ನಾಟ್ ಇಂಚ್ ಇಟ್ ಇಸ್ ಫಿಕ್ಸ್ಡ್ inched fixed. So one end inched, other fixed. And now you see the shape here. Now we see the shape here. The shape actually changes something like this. Is sarina nanu bidstiradu nodi? Sarina idu? Is it right? ಉಲ್ಟಾ. ಸೊ ಬೇಸಿಕಲಿ ಇಲ್ಲಿ ಈ ತರ ಟರ್ನ್ ಆಗುತ್ತೆ, ಬಟ್ ಇಲ್ಲಿ ಈ ತರ ಇರುತ್ತೆ. ಓಕೆ, ಸೊ ಇಟ್ ಈಸ್ ಲೈಕ್ ದಿಸ್. ಹಿಯರ್ this is actually, you can see that more than half of the length of the column participates in taking, in bending. More than half of this. Half andre isto, half andre isto. So this is more than half. So more than half andre, instead of dividing it by 2, I am dividing it by root 2. Okay, so LE is actual length divided by root 2. So that means ಇಲ್ಲಿ ಏನಾದ್ರು ನಾವು 200 mm ಕೊಟ್ಟಿದ್ರೆ 200 divided by root 2 ಮಾಡಿಬಿಟ್ಟು then we have to substitute this value. Okay, so the condition is given, so according to the condition you should substitute this value. So they will say one end hinged, other end fixed. In that case effective length is L by root 2. Okay, ಬೇರೆ ಏನು ಕಾಂಬಿನೇಷನ್ ಮಾಡ್ಬೋದು ಇವಾಗ? both side fixed. Okay, both side fixed. So here I'll fix both sides. But apply ಮಾಡಬೇಕು load. So here I'm applying load. Here also I'm applying load PCR. Here also applying load PCR. But this block is quite thick, into which I can actually embed this material. ಈ ತರ ಇದೆ. The column goes like this. The column goes like this to either sides. Now if you are applying load, can you tell how it will actually bend? How it will actually bend? Whether it bends like this? Okay, whether it bends like this? No, because this end is held. It is going inside this. It is going inside this. So both ends are like this. Both ends are actually held like this. So therefore, this is actually like this. You can see. Here you can see that this part of the beam column doesn't participate in bending. This part doesn't participate in bending. Only around this part is actually participating in bending. So the effective length which is actually under bending is actually L by 2. It's not root 2 here. In case root 2, because the part of the curved beam is, so the part of the curved column is larger. Here the part of the curved column is smaller, because both sides are end like this. Okay, and then So now what I should write this as? ಏನಂತ ಬರೀಬೇಕು ನಾನು ಇದನ್ನ? Both ends fixed. And then of course ಇದರಲ್ಲಿ ನೀವು you can see ಈ ತರ ಇರುತ್ತೆ. Since there is not much time, I am trying to minimize the effort in drawing. So you're trying to apply load to this block. Now this block is holding this, and it is bending like this. So it will bend like this, something like this. Okay. And the last one, the last case ಹೇಳ್ಬೋದಾ ಹೇಗಿರುತ್ತೆ ಅಂತ? One end fixed. One end fixed. One end fixed. Other end directly apply ಮಾಡೋದು load. You can see this difference. Here there is restriction for going sidewards, but here there is no restriction. Here there is no restriction. So what will happen is that this can start bending in side. It can start bending to sides. So since there is no block here, you can see the load is being applied through a block which is restricted movement like this. Here there is no restricted movement. So therefore what happens? Because of this load, this beam starts to, now this column starts to bend like this. This is the applied load PCR. This is the applied load. What is the crushing load? The Euler's crushing load. This is the load, and this is how it bends. Okay? It is this case. In this case, the effective, you can imagine that this beam continues like this. Now this beam continues like this, and this whole beam is participating in bending. So therefore, in this case, you can see that the effective length is how much? 2 times the actual length. So the effective length is actually 2 times the actual length. So in this way, you can actually find out the Euler's load for different cases. Now what do you write for this case? One end fixed, other free. In this is arranged like this. Here it is free to move sidewards. Okay, so in this case, effective length is 2 times the actual length. So there will not be any questions on this, but just to remember these values I am giving this. Maybe in the examination we can ask a question, what are the various types of the end conditions in columns, and write the values for effective lengths. Okay, it can be given in the examination. Please look into this, be familiar with this. Okay, then in that case you will have to write all these end conditions and give the effective length for each case. Not for the exams, maybe for the examination or somewhere. Okay, because this is a very easy question. Okay, now having actually done this, can we solve a problem? Some random problem we will take. Now we will actually take the example of some column like a scale. I think you got a scale which you now is used to write lines, no? A long scale, 1 foot scale we will take. 1 foot scale. 1 foot scale, okay. That scale is made up of what material? Plastic. Plastic may have a yield stress of around 20 Newton per mm square, or even still less. Okay. So with that, I think we don't want that. We'll take we don't want failure stress. We want Young's modulus. Young's modulus of plastic. Steel is around 200. So plastics can be around. Estirutte. Steel has got 200 GPa Young's modulus. Stiffness. Plastic estirbodu. Around 10. Around 10. So let us take it as 10 GPa and solve it. Okay. So we are trying to check at what load that scale fails. Okay, so we'll use this. So shall we erase this? Okay. Okay, you try to guess. What can a 1 foot long scale? Now, whatever the scale that you are using is actually half foot, no? 1 foot long scale, plastic scale can take a load before it fails. ಎಷ್ಟು load ತಗೋಬಹುದು? 1 kg ತಗೋಬಹುದಾ? 1 kg, 2 kg, 3 kg. What is the guess? 1 kg. 1 kg you say. 1 kg is too small. Okay, ಇರಬಹುದು. ನೋಡೋಣ. It's your guess. Let us see whether it works. A scale to dimension ಏನು? A scale to dimension of the scale na will try to make it as a rectangular scale. You can try to make it as a rectangular scale. Most of these are not. Most of the scales, let us say that scale is like this. Okay. A scale length is 30 centimeter. That is 300 mm. What do you think is the thickness of the scale?
2 mm, sir.
2 mm. ಈ ಸ್ಕೇಲ್ ವಿಡ್ತ್ ಎಷ್ಟಿರ್ಬೋದು? 2.5 or round it up to 3. ಎಷ್ಟಿದೆ ನೋಡ್ಬಿಡಿ. 2.5. So let us say it is 25. Okay. Now the scale will give you different. Crippling loads based on how you are holding it. What is the first case of holding that we saw? Both ends hinged. So let us try to see if this scale has both ends hinged. If this scale has both ends hinged, what will be the maximum load it can take, which is given by PCR, which is actually pi square AI chi minimum divided by L square. So you know 3.14 and E is how much I said? E for plastic is around actually 10 GPa. So 10 GPa is actually 10 Newton per mm square. Sorry, that is MPa. So this is actually 10 into 10 to the power of 3 Newton per mm square. So last time we said 1 MPa is 1 Newton per mm square. But we know 1 G is actually 10 to the power of 3 megapascal. This is giga. This is mega. Okay. So this is 10 into 10 to the power of 3 Newton per mm square multiplied by I minimum. And what is this LE you will take now? 300 only because both ends are hinged. Easy, no? So both ends are hinged. 300 mm whole square. Now I know everything, but I don't know I minimum. So let us find out I minimum. So let us find I in both the cases. You know that I will be minimum. By common sense we know. If you keep the scale like this, I will be minimum. If I keep the scale like this, I will be maximum. You know, if you want to bend the scale, it is very easy to bend like this. Suppose if you keep the scale like this, it's very difficult to bend. So if you keep like this, what is this width? B. B of the scale. It is scale it is the length of the scale. Okay. There is a section of the scale. This is the section of the scale you want. Now you are looking at the section of the scale for bending. Bending is a cross section in point. Okay. Now this is 25. What is this? This is 2 mm. If you keep like this, then B 2 mm d cube 25 m cube, then I value will be larger here. So I is equal to BDQ by 12. I is equal to BDQ by 12 will be larger in this case, but it will be smaller in this case. So definitely by keeping like this, we will have I value less. So I don't want to keep the scale like this. I don't want to keep the scale like this. I want to keep scale like this if I want to break it. So that is I minimum. So inertia for bending. Inertia for bending is less in this direction, more in this direction. So I don't want to use this. So I want to use this directly because my sense says that this is easier to buckle. So in this case, I is equal to BDQ by 12. B is how much? 25 mm. What is the depth? 2 mm. Whole cube divided by 12. What is the answer? 16.66 mm to the power of 4. Understand? How many are confirming? Only one person calculated. 16.66. Okay, I can go ahead with this. Now I have to substitute this value here. I am substituting here PCR. What is the value that you guessed? You just wait 1 kg. 1 kg is actually 10 newtons. So now we are calculating. So PCR is equal to 3.14 into 10 to the power of 4. So 10 into 10 to the power of 3 Newton per mm square. So I is actually 16.66 millimeter to the power of 4 divided by LE square. LE is how much? Length is how much? So in this case, we also know that LE is equal to L for both ends inched. For both ends inched, LE is equal to LE. So we are actually taking this as 300 mm square only. So therefore, which one? Okay, pi square. Okay, sorry. This is pi square EI. This is pi square 3.14 square. Okay, so what is the answer? So here you can see mm square, this mm square, this becomes 2. Okay, em square ಅಲ್ಲಿ mm to the power of 2 ಅಲ್ಲಿ ಕ್ಯಾನ್ಸಲ್ ಆಗಿ 2 ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಮತ್ತೆ em square ಮತ್ತೆ em square ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಕೊನೆಗೆ ಏನು ಉಳ್ಕೊಳ್ಳುತ್ತೆ ಯೂನಿಟ್ ಅಲ್ಲಿ? Only Newton is remaining. In this only Newton is remaining. mm square ಇಲ್ಲಿ m to the power of 4 ಇದೆ. ಅದರಲ್ಲಿ 2 ಹೋಗುತ್ತೆ. ಕೊನೆ mm square ಉಳ್ಕೊಳ್ಳುತ್ತೆ. This m square and this m square gets cancelled. Only what is remaining? Newton is remaining. What is the answer that you got? 18.25. 18.25 ಅಂದ್ರೆ ಎಷ್ಟು kg? 1.8 kg. Okay, are these equations useless? So useful, no? We guessed 1 kg ಎಷ್ಟು load ತಗೋಬಹುದು. We felt more load it can take. By equation it is giving it can take 1.8 kg of load. This guy Euler made this equation 300 years back. After 300 years, if you struggle to use what equation he has made, then whose fault it is? We are not asking you to make equation, we are just asking you to use the equation he has made 300 years back. Okay? Just use this equation. So this is the load when both ends are inched. Suppose if somebody asks, what would happen if both ends are fixed? ಜಾಸ್ತಿ ಲೋಡ್ ಬರುತ್ತಾ ಕಮ್ಮಿ ಲೋಡ್ ತಗೊಳುತ್ತಾ? ಜಾಸ್ತಿ, definitely it will take more load because here LE will be how much? L by 2. So for both ends fixed, ಗೆ ಇದರಲ್ಲಿ ಏನಿಲ್ಲ. You have to multiply by this width 300 square and again divided by 150 square. So for both ends fixed, LE is equal to half L or L by 2. L by 2. L by 2. Same equation only. Everything remains same. I think everything remains same here as it is. Only what changes is here you are dividing it by 150 mm square, which is half of it. Anybody got the answer? So then it almost increases by 4 times.
73.
It increases by 4 times here. 73.0 what? 0.04 newtons. So that means now it can hold 7.3 kgs. If you are actually holding the scale both sides, then its capacity to take loads increases by almost 4 times. So this is PCR when both ends are fixed. So like this you can solve numericals.